Okay, hello everyone. Now we will be solving the algebra questions, equations and inequalities from different papers of paper one. Now these are the first question, usually the first question of the papers, I will not solve all the questions, but we can go through the memorandums together and we can figure out how to get marks, how to get full marks, or how to get part marks if we can't solve the question in different ways, or at least how we shouldn't lose any mark, so we can talk in this stuff. And as you see, the first questions will have a factorization question. It can be either common factor, grouping, or difference of two squares, or a trinomial. So that's the trinomial. We will just find the factors of 12. And then we will write x minus 4 and x plus 3, and we will be able to write the answers. And then the second one, we have already given a term which is factorized. Actually, it's an inequality, as you see. There is 0, less than 0. But then the term, one of the factors, x squared plus 1, this expression is always positive. Since a perfect square of any number in a real number is positive, that's why when you increase it by 1, so it doesn't affect the left side of inequality. So actually, whenever 2x minus 3 is negative, we will have this term on the left side become negative. So actually, the question is just going to focus on, in such questions, we'll just focus on the first term. Whenever 2x minus 3 is negative, that's the answer for x. So it's basically solving a linear inequality. So you can leave x alone. So in such cases, we can just say x to the power of square is always more than or equal to 0. And if you increase it by something like x squared plus 3, for example, it's then definitely more than 0. All right. We can say it's more than or equal to 3. The minimum value is 3. And it's definitely more than 0. You can even think in that way. What else we could have? Like 2 to the power of x is always positive, or 5 to the power of x is always positive. It doesn't even become equal to 0. So if we have such things in the expression in an inequality, we can ignore. So we are basically ignoring the first factor, the second factor, and we'll just answer the question according to 2x minus 3. All right. So the first one I didn't write, but we must factorize, remember. And what are the possible factors? It can be common factor, or it can be grouping. We can say grouping, or we may have difference of two squares, or as in this question, it can be a trinomial. Okay. Now, number 3, whenever you see a question rounded off 2 decimal places and stuff, so you understand we will be using quadratic formula. It's not a factorization. So we will use a quadratic formula, which is given in the formula sheet. And then in using quadratic formula, just be careful of assigning those values, because we must have our expression in standard form, remember? So I don't want 7 on the right side of equation. It must be a standard form. It must be in standard form. And standard form is like what? For a quadrilateral, ax squared plus bx plus c is equal to 0. So when our quadratic equation, whenever we have all the terms of quadratic equation is on the left side, and the coefficient of x squared is a, and coefficient of x is b, it can be positive, negative, any real number, it can be fraction. And then the constant term without x or x squared is is c. So then we can just plug in those values into our quadratic formula. So the quadratic formula is minus b plus minus in square root b squared minus 4ac divided by 2a. So it will be just like that, and we will get the answers. And rounding off is important. We may lose marks, just be careful. It must be 2 decimal places correctly. So please do not lose any silly marks here. And 114, we will see small questions in this way, but solving a question which has root, we must leave it alone, so that when we are taking square of this expression, we wouldn't have any problem. like we must leave the root alone. Let's say leave root alone as a first step. Leave the root alone. So how can we do that? We can take minus x from left to right. Okay, so we can take minus x from left to right. And what will happen then is going to give us an equation. One side is root, only root something, and then the other side is x and 4, x minus 4. So now we can square both sides of the expression. Okay. And another part which can be wrong in such questions, 2x minus 5, the other side become x minus 4. So when you square the left side, when we will square the left side, it just will remove the per root. Okay, that wouldn't be a problem. But when you square x minus 4, many learners do mistakes here, just be careful. We must be able to correctly square x minus 4. If you are losing marks, if you see you are not getting the right answer, whatever in the memos are, you may just multiply x minus 4 and x minus 4 itself twice. Okay, so it is going to be x squared minus 8x plus 16. But if you have trouble in getting such an answer, so you can write x minus 4 twice. Basically what we did, we square both sides of the equation. And then the rest is, it's solving a trinomial. We can take all the terms from one side, make one side equal to 0. And yeah. One thing before we finish in 1.1.1, whenever there is a root question, we can say answers has to be checked. Answers validity, let's say that way. So we may end up two possible answers because it's a quadratic equation as you see. So the validity, answers validity must be checked. Must be checked. So how can it be done? We can basically substitute the answers into the original equation. And if it's satisfied, if it's correct, then both can be possible answers, or we may have to ignore, we may have to reject one of the answers, and we may have to accept the other one. Okay, or there may be a question we have to reject both. There may be possible rejections. Let's say that way. Okay, now and the last one, actually not the last one, the second type. Let's say there is solving equations, solving inequality, quadratic equations. And another famous question is simultaneous equations. One is linear, one is quadratic. But what we see as the first one is given as an exponential form. It's kind of an exponential equation. Now we have two unknowns, and then we have two equations. Now, as you see, the second one is quadratic. So that's the one we will not start, because we can't just leave x or y alone easily in the quadratic expression. But now in the other one, it is usually a linear equation, but here it is given as an exponential form. How can we get a better idea in this second option, sorry, in this linear option? So how can we convert it? So that 32, it must give us an idea about what? 32 is a perfect power of 2, which is 2 to the power of 5. So we can actually rewrite the first one. So it's 2 to the power of x plus 3 is equal to 2 to the power of 5y. And you know the relation, if the bases are same, as long as it's not negative, sorry, it's not 0, we can have the or 1, so we can have the power same. So that's our x plus 3 is equal to 5y. This is our linear equation. So basically this question is solving a quadratic equation and a linear equation. And in linear equation, we start solving these questions from the linear one. Remember, we have to leave x or y alone, whichever is easier, it doesn't really matter. And in this question, which one is easier to leave alone is x. So we can say x is equal to 5y minus 3. So wherever there is x in the quadratic equation, we will square it. For example, in the first term, then we are going to times it with y. Wherever there is x, we are going to substitute it with 5y minus 3 and carry on solving. Okay, and then this question 1.3, it's asking when it will be real and when it is undefined. So to be real, we must have inside an even root must be positive. You can say that way. So, and basically we have square roots, remember. So what happens if inside a square root is negative? So it's not a real number. Remember, we even say not real solution. So if we end up such situations, that's not even a real number. So to be real, inside an even root, it can be the fourth root or the sixth root, but usually we have square root. Okay, so usually we have square root. So inside a cube root, we don't have any problem with a negative number, like cube root of -8, for example, is -3. Sorry, -2. So even the calculator gives an answer in a cube root of -8. That's not a problem. A negative number inside an odd root, like 3. So inside the cube root of -8 is -2. So, but the problem is a negative number inside a square root or fourth root, whatever. Now that's what we want. Inside must be positive. And to be undefined condition happens whenever there is a fraction. So whenever there is a fraction, there is numerator and there is denominator. So whenever denominator is 0, denominator is equal to 0. So that's an easier answer. We can just get it first. So for example, in this case, what is denominator? 4 plus x. So when does it become 0? So when x is -4. So that's the answer. So it becomes undefined when x is -4. What about that first one, the real condition? We will be checking inside positive. So it's actually an inequality question. As you see, 8x minus 4x squared must be positive. Can it be 0? Yes. 0 is not a problem at all. So we will be solving this inequality. Now, inequality questions, let's factorize it. 4x as a common factor. So we have 2 minus x is more than or equal to 0. So we can say there are critical values. Critical values are what? X is equal to 0 and 2. So on a number line, we can see what's happening because we will be taking less than 0 or more than 2 or in between. So just be careful. There is 0 here. There is 2. Which part of this number line satisfy what we want? We can check with a testing value. For example, I used to say TV. So testing value, like what? X is equal to 1. Any number not to 0 or 2 can give us an idea. So x is equal to 1 gives what? In the first expression, x is equal to 1, 8 minus 4 gives 4, which is positive. So where is 1 states 1 is in between 0 and 2. So the number that we substitute 0 and 2, 1 is inside between 0 and 2. So that is the section, the first thing we write is positive because it's positive. I don't care what is it, but it is positive, it is 4. And then after 2, it should change the sign. And before 0, it should change the sign. So then finally, we will be just checking which interval are we looking for. This inequality says positive conditions. That's why I will be shading and taking the in between. And then we can write the answer. The answer will be more than 0 and less than 2. Can it be equal? Yes, equality is not a problem at all. All right, so that was that here first question. And the memorandum is, let's just quickly go through anything that we didn't mention. We can just remember from the memorandum. I just want to say this, factors is a mark in the first question, okay? Do not just write the answer is 4 and minus 3. Show your factorization so you get full marks, not just the answers as you see. The second one, the idea that x squared plus 1 always positive, and then it's just about the first factor. So 2x minus 3 is less than 0, so x is less than 3 over 2. Okay, and some of questions in this way, as you see in the memorandum, they even accept answers only and you get full marks from that, without writing that x squared plus 1 always positive, or without writing 2x minus 3 negative, whatever. It is possible to get full answer for the answer in such questions. But you better write, like how will you be able to just write, x is less than 3 over 2? You better write 2x minus 3 less than 0 and then that. Okay, and the questions in using quadratic formula, writing standard form can be one easy mark, please do that. And substitution into the formula is good. And obviously correct answers with correct rounding off, so you get full marks in the such questions. And questions with a square root, with a root, as you see, you're isolating search, so leave root alone, that's first step. Then you square both sides, and then you solve that quadrilateral, put everything one side, as you see. Now we got two possible answers according to this quadratic equation, which is 7 and 3, but we have to reject, so we must check which one works. So 3 is a problem, like y. Look at the expression. When you substitute 3, what do you get on the left side? 2 times 3 is 6, minus 5 is 1. So root 1 is 1. So 1 minus 3, okay, it gives negative 3. It doesn't give negative 4. You see, that's wrong. But when you substitute 7, does it work? Just have a look. So 2 times 7 is 14, minus 5 is 9. So root 9 is 3. And then what do you get? 3 minus 7. That's correct. So we don't have any problem with 7, but 3 doesn't work. So you have to mention that to get full marks again. All right. And then inequality question, quadratic, simultaneous equation question. As you see, we got the expression from the exponential equation. We got a linear equation with the powers, solving that. And we substitute into our quadratic one. Open the brackets. It's some algebra. Just be careful. Don't make any silly mistake, any addition, subtraction, or minus error. And then you will get two answers for y. And for each answer for y, we have to get the x values, corresponding x values. And how do we get them? We don't need to show how we get it, but we can actually use that first equation, the linear one. When you substitute y with, for example, 1, 5 times 1 minus 3 gives us 2. So that's the first set from the equation. And when you substitute y with 1 over 5, what do you get? 5 times 1 over 5 is 1. 1 minus 3 is negative 2. So you get the set of solutions in that way. Okay, and yeah, I think we are done with this question. Let's carry on. So as you see, we saw a full question, almost full question of a paper. So from now, we can just skip if there's a similar question, or if anything important to be mentioned, we can mention that. So something is already factorized. It's like a cubic, we can say if we expand it, it's a cubic expression. We will be solving for a, not x. That's fine. Now, when do we get 0? Whenever each value is 0, it can be a 0 answer. We can get a 0 answer when we multiply 3 numbers whenever one of them is 0. But yeah, this just reminded me, we have to express our answers as well. Like the first one to be 0, we know, okay, that's easy when x is 2, or second one become 0 when x is 1, and then the last factor can be 0 when x is 7, minus 7. But you see, x cannot be all these numbers at the same time. So what do we do then? We must write or in between, okay? Whenever x is or whenever x is 2, or 1, or negative 7, okay? That's sometimes separate one mark. So you shouldn't write and. Like x cannot be 2 and 1 at the same time. That will be a wrong idea, you know. So the meaning doesn't match there. So we must say, okay, it's not x, by the way, sorry, it's all a's. So whenever a is 2, or a is 1, or a is negative 7. All right. Then the next one, can we factorize it? In grade 11, you learn this completing square, like we can even try with completing square, but it's not examinable. So you can use it, nothing's wrong. But the quadratic formula wouldn't be a problem at all. But just to remember, to have an idea with your grade 11 work, how does the completing square used to work? You leave x squared minus 2a alone, let's say that way. So take 4 from left to right. And to be able to get a perfect square from left side, you add half of the square of coefficient of a, which is coefficient of a is -2, half is -1, and then square it is 1. So you add 1 both sides. And then there you see that's a perfect square. And what square is that? A minus 1 squared. The right side is 5. So what do we see? You root both sides. Don't forget plus minus root 5. And finally, possible answers are a minus root 5 and a plus root 5. And it doesn't say decimal places, whatever, so you can leave it like that, or you obviously get 2 possible answers with the correct 2 decimal place. So that was how we used to solve questions with completing square. Now there's a root question, same idea, you square both sides. Don't forget checking your answers at the end, okay? You may need to reject one of the answers. There's an inequality, that's fine. 1.2, simultaneous equation. So how could this work? Actually, a squared plus b squared is 2 and a plus b is 2. We shouldn't just write the answers. You see, let's actually mention it. Strange, because you can easily guess, isn't 1 squared plus 1 squared is 2 and 1 plus 1 is 2. You can just say a is equal to 1, b is equal to 1. However, no marks for given answers only. So we must show those answers, whatever we are getting. So how can we do that? That means they expect us solve using that quadratic inequality, simultaneous quadratic equations idea. So that's our quadratic part and the one side, and the other side is our linear part. And how we used to solve linear equations, remember linear quadratic simultaneous equations, let's say that way. We start from the linear part, we leave a or b alone. So I'll leave a alone. So what do we say? A is equal to 2 minus b. And into the second equation, instead of a, I can substitute this 2 minus b. So 2 minus b squared plus b squared is equal to 2. So solving this should give us answers. Let's just carry on. What do we get when you solve square? It's 4 minus 4b plus b squared. Now we have another b squared is equal to 2. Okay, now everything one side. Let's put everything on one side and see what do we get from here. We can get 2b squared and then minus 4b. What else? Plus 2 is equal to 0. So divide everything by 2. B squared minus 2b plus 1 is 0. So it's a perfect square, b minus b squared. As you see, we have only one answer. It's a quadratic equation, but quadratic equations may have only one answer. So b is 1, which is the only answer. Now, how do we get a? Substitute b into our equation, the linear one. Remember, a is 2 minus b, so which is 2 minus 1. So that gives us the answer for a as well. So that's how we get a is equal to 1 as well. Okay. So they don't expect us to guess the answer is 1 and 1. All right, and 1.3 again looks a little bit different. We want to leave y alone. Y is already alone, but in simplest form. Basically, we will keep taking square of, because we want to get rid of those square roots. So that can be the method. You can say x squared is what? X times root x. Okay. Let me start from there. Or we can just removing the square roots. I think I'll go not taking square roots, taking square of both sides. I'll go with this idea, starting from the most inner perfect square, square root, I mean, because square root of x, you know, it's x to the power of 1 over 2. and it is times by another x. So that makes what? What is x times x to the power of 1 over 2? Together, remember there is 1 as the power. So when we add them, add the powers, when we combine them, we got x to the power of 1 plus 1 over 2 is 3 over 2. Now this is inside square root. So we just have that. Now, how can we get rid of that square root? We divide the power by 2. Basically, it becomes x to the power of 3 over 4. When you divide 3 over 2 by 2. Now, there is another x, which is this x. I can just write now. There's the last x, there is one more x. So what is this then? X times x to the power of 3 over 2. Same story, we add the powers. And when we add the powers, 1 plus, there was this invisible 1. 1 plus 3 over 4 is x to the power of 7 over 4. So, and the last step, because this whole thing is inside the big root. So we can say it's y is equal to root this. So now final answer, how can we get rid of root? We'll just divide by, we'll just divide the power by 2. So then y is equal to x to the power of 7 over 8. So that will be the answer. So what we use to solve this question, I can just write here, when we have like a to the power of n, it's a to the power of n over 2. And if n is 1, it's 1 over 2, or whatever n is, you divide it by 2 to get rid of. So we have done it like 3 times. So that method, where we applied it in this step, we applied it in that step, and we applied it in the last step, because we were removing 3 square roots. So we applied this idea 3 times in this question. Okay. All right. So first question, second one is this quadratic formula inequality. There is rejection mark, remember, that's just highlighted again. You get a mark for rejection. And yeah, it's an inequality question. Let's see. And the next one, yeah, next one is how we solve that question without guessing. And the last question, they take squares of both sides. Nothing is wrong. It can be done in that way as well. The answer is 7 over 8. Yeah, so the same answer. You can solve in any way you want. Okay, now we can speed up and see any different question is over there. First question, second question is quadratic formula. First question already factorized, just write the answer. Number 3, that's a root question. We square both sides. Remember the rejection inequality question. Be careful with the intervals in this case. Okay, and then okay, this looks a bit different. Solve without calculator. 1.3 is fine. You can just leave. Which one is easier to leave alone? Why? Because just the coefficient, whichever the term has coefficient 1 or minus 1, that will be easier to leave alone in a linear equation. Okay, so you leave y alone and substitute wherever y is. We will substitute 3 minus 2x. All right, but 1 over 1.2. How can we simplify this expression? Now, remember this is cube root now. In square root, we divide by 2. In cube root, we divide by 3. But let's first fix the thing inside. So we can say it is cube root of what? It is cube root of x to the power of -7, isn't it? So because it is 1 over x to the power of 7. So then that's the cube root of that. All right. And then remember, this can be written as x to the power of -7 over 3. That's okay. But it says no calculator. Now, 128 should give us an idea. It's kind of a special number. It's one of the powers of 2. And if you forget, you might have forgotten, you can write them. So it's 2, 4, 8, 16, 32, 64, 128. You see, 256, 512, 1024. It carries on. But what do you see over there is 128 is which? 1, 2, 3, 4, 5, 6, 7th power of 2. And we have 7 in the question. That's interesting. Huh? So that is going to help us to make something over there. because 2 to the power of that thing is equal to, sorry, x to the power of minus 7 over 3 is equal to 2 to the power of 7. So that's my lovely equation. Now, how can I leave x alone? We will use a rule, power to the power rule, like to have the exponent of x1. You see, I don't want minus 7 over 3 here. I just want x alone. So to be able to have x alone, what I do is basically, I will take the power, what power of both sides, the reciprocal power of 7 over 2. So I can just multiply, so then both sides, I can just do this, multiply it minus 3 over 7. So that, but I have to do it for both sides of the equation, okay? So what happens there? So you get x to the power of, what is minus 7 over 3 times minus 3 over 7? The negatives cancel each other, the 3s and 7s cancel each other. We got a very nice answer. We will just get x alone. So that was the point, that was the reason, that was the aim. So it's x alone. So what's this thing here? 2 to the power of 7 times negative 7, 3 over 7. Okay, at this stage, you can use calculator. Like if you want to, if you are not sure what is 7 times minus 3 over 7, nothing is wrong to using calculator there. So the answer is negative 3. So basically, we can leave the answer in this way, or we can say x is equal to 1 over 2 cube, or we can say x is equal to 1 over 8. They all accepted, or they accepted. Yeah, that question was a little bit different since it says no calculator. We have to remember all these square root and exponential rules which can be applied so that we can leave x alone. Okay, in solutions, nothing looks different. As you see, inequality question, root question, and everything. So there are two ways of solutions here. Answer is 1 over 8, yes. So you can go through whichever you find easier. But I showed the way we solve together. Now, that's another paper. Looks some different questions, not a lot, but just a look. So a function is given. So when does f of x become 0? It's basically, remember, the x-intercepts of the function. And it's the x times 4 minus 3x is 0. So it's basically, it's already factorized anyway. I'm just going to write the answers. X is equal to 0 or 4 over 3. And then when does f of x become equal to negative 2? It's like there's a point on the function if you are thinking it's a parabola because it's a quadratic equation. So when the y values become minus 2, we may have two answers or one answer. Now we have to open the bracket. Remember, it must be in standard form. To be able to use quadratic formula, we must have something in standard form so we can decide and we can say what is A, what is B, what is C. So that will give us the answer with quadratic formula. And whenever it is more than 0, it's inequality question of that expression wouldn't be a big problem. And the question here, so I want to do this again. It's related to this last question we solved. Firstly, we will leave that exponent, the exponential term alone. So x to the power of 0.75, you divide both sides by 2, you're going to end up 1 over 8. Because even this question says no calculator, you see, without using calculator. Like if you want to divide 1 over 4 by 2, you can use in that step, using calculator wouldn't be a problem. Like you shouldn't use logarithmic functions or anything related that we are using solutions with calculator. Now the same idea, I want the power of x1. So what should I multiply? What is 0.75 by the way? So we can just rewrite the 0.75 is 75%. As a fraction, what is it? 3 over 4, isn't it? So actually the question is x to the power of 3 over 4 is equal to, and let's just fix 1 over 8 as well. It is 2 to the power of negative 3. So 8 is 2 cubed, but you're taking it. And now remember this famous step to be able to have the exponent of x1. So we multiply, we take the 4 over 3rd power for each side. So finally, this is how we got x alone on the left side, and the right side to the power of 3 times 4 over 3 is 4. So the answer is 16. Okay, now 1.3 looks like a simultaneous equation. Yes, all is fine. Just like the sigma notation makes it quite different. Okay. So this is a quadratic equation, the first one. Nothing is wrong with that. I wouldn't have any problem with the quadratic one. But then the one with sigma notation, it should be the one with linear expression. But why is it like that? Now, so they definitely want to test your understanding sigma. It means the sum of such values inside in front of sigma, that notation, substituting for the k values. Okay, it's starting from 3 and ending 4. So it's basically just 4k is 3 and 4k is 4. So I have to rewrite that part. So the right side is 5y. We don't have any problem with the right side. Right side is okay, that's 5y. But I have to find out what is on my left side here. So when k is 3, we got x times 3 minus 2 square, when k is 3. And then plus, I will add, when k is 4, it is x times 4 minus 2 square. That's my left side. And so it is what? It is going to be, the first one is x times 1, so it's x plus, so that's 2 square is 4x, so it's 4x. So what do we get from this whole thing is basically 5x on my left side is equal to 5y already given on my right side. So I can say x is equal to y. So that's a nice linear equation. Huh? I can just substitute wherever there is y, I can substitute with x, that means. And then we can solve it. All right, that's it. Oh, there is last question, 1.4. It is given that for which values m will be non-real. Oh yeah, the same idea. What was that means, like non-real? So we said inside root. So 36 minus x, 5 plus x. This must be less than 0. Can it be equal to 0? No, if it is 0, that is root 0 is 0. That's real. That's not a problem. So how do we solve this? It's an inequality question. You can open the brackets. It's x 5x. Sorry. Minus 5x minus x squared is less than 0. Maybe we can take all one side, and then it's the trinomial, so it becomes x squared plus 5x minus 36. We need to find the critical values, the factors. We can draw a number line. Okay, you can just solve from them in the same way. And you will write the answers, what makes inside negative, remember. It's a 5-mark question. Okay, I think that's all look fine for now. In some questions, you can even use that, when you find critical values as a testing value or thinking as a parabola, you can even use that parabola shape in solving your questions. Here, anything not right? Okay, first one is fine, the second one, third one, inequality. Okay, only this 1.3. Looks quite different. Let's have a look and try to see what we can do in a question which has root and exponents, which you can struggle and which they can ask. So whenever there is plus and minus in between exponential terms, we will factorize, and most probably it is common factor. So basically, there is a plus and minus in between exponents. Then what do? We must factorize. And 99%, it is common factor, okay? Common factor. So let's keep that in mind. And it always works that way. Now, we need to fix that first. And what about that root n? Don't worry much about root n. It's going to be like, if we have nth root of a, I can tell you, it is a to the power of 1 over n. Or if we have nth root of ax, it's going to be a to the power of x over n. Basically, whatever the thing inside, finally, we will divide the exponents with n. So that's the idea of nth root. So that shouldn't worry about you. All right, now let's fix inside first. And fixing inside and finding the common factor, that 10 to the power of n. So I will just rewrite. Okay, let me write the whole thing, not just inside. So I'll split 10 to the power of n as what? 2 to the power of n. 2n and 5n. And then plus, I will split the 2 to the power of n plus 2 is 2n times 2 squared. So that so that I can see there's this common factor. What's common factor? 2 to the power of n. That's in numerator. Now I'll draw the line. Yes. Oh no, it wasn't a straight line. Let me draw my own hand. Okay. Now the one below is 5 to the power of 2n. That can be written only 5n times 5n. See, it is the n plus n is 2n. It's the square of 5n, by the way. So we can think like 5 to the power of 2n. 2n is same as 5n square. Nothing is wrong. Or 5n times 5n, because n plus n is 2n. Or it can be seen as 5 square to the power of n. So 5, it's 25 to the power of n. So that's correct as well. Because the question might be given as 25 to the power of n. It doesn't really matter. That's what we will be writing. So I split in that way. Now the second one you have 4 times 5n. Okay, let me not change it. So now I can freely use this idea of having common factor. So what is common factor in denominator and what is common factor in numerator? So let's draw our line. As you see in numerator, we have 2 to the power of n. As you see, that's the common factor, 2 to the power of n. What is left behind? We'll see. And in the denominator, there's 5 to the power of n. So we'll just write what is left behind. What is left behind in the numerator? When you take that's 5n and plus 2 square, which is 4. And what is left in denominator? There's another 5n, and then there's plus 4. Oh, that's nice, because you see, they will cancel. So that's so nice. Now, that makes our job kind of much easier, because it's 2n over 5n, it is the nth root. So we'll basically divide the roots by n. Or I can even write it in this way, 2 over 5 to the power of n. And so what's final answer then? N over n. Remember those rules that I wrote on the left top. So the answer is 2 over 5. Then you can smile. Okay, so just be careful how you solve this question. You can even see the steps maybe in the memorandum. When you get the file, yeah, the answer will be 2 to the power of n. Yeah, all will be fine then. We are about to finish for this equation inequalities algebra section. As you see, it's the same idea, similar questions. Be careful with nature of roots. Sometimes there are questions, nature of roots about discriminant. Not in this one, but I just mentioned it down there as an extra idea in case of nature of roots to remind you. Nature of roots, it's the discriminant, it should remind you. And it helps some questions a lot. And what is that? It is b squared minus 4ac of a standard form. Actually, it is the part inside square root in quadratic formula. Remember, inside quadratic formula, we have this b squared minus 4ac. So what are the possible conditions then? Remember, it can be less than 0, or it can be equal to 0, or it can be more than 0. And that gives us less than 0 is the one we say no real solution, because inside that square root becomes negative. So we say no real solution when inside square root is negative, remember. And then equal to 0 gives us one root or two equal roots, one solution. Okay, let's write that way. Two equal solutions. It's the same idea. And when it is positive, we have two real roots. Basically, as long as it is more than or equal to 0, then we will be having real roots. That wouldn't be a problem. Okay, just that nature of roots gives us the idea of understanding number of solutions in a quadratic formula. All right, so all is fine then. I wish you good luck, and I hope you get your maximum mark in this first question of paper 1. Do not lose silly marks by rounding off or just a silly mistake with the powers, with the signs plus or minus, or with the factorization. Just be careful, and hope you can get the most out of this 25 mark section of paper 1. Bye.